Hi, welcome back. I'm Erik Brynjolfsson, and this is the Stanford Digital Economy Lab Lunch. And we're going to have Daniel Rock presenting his research on Work2Vec. We're doing this hybrid for the first time here. So you can see around us, there's a bunch of us in person here at Stanford University and hundreds more of you out on Zoom. Those of you who are on Zoom, please send us your questions via Q&A. The plan is for the first 45 minutes or so, we'll take clarifying questions. And then the last 10, 15 minutes, we'll do more broader general questions. Let me introduce Daniel a little bit. Daniel is an assistant professor of operations, information, and decisions at the Wharton School at the University of Pennsylvania. His research is on the economic effects of digital technologies, with a particular emphasis on the economics of artificial intelligence. He's recently worked on studies addressing the types of occupations that are most exposed to machine learning, measuring the value of AI skill sets to employer firms, and adjusting productivity measurement to include the investments in intangible assets. Daniel got his BS from the Wharton School at the University of Pennsylvania and his MS and PhD from MIT, where I got to hang out with him a bit. Between his undergraduate and graduate studies, he worked as an algorithmic trader at DRW Trading. Welcome, Daniel. Take it away.
Thanks so much. Thanks to Estelle for having me. Thanks for inviting me, guys. It's exciting to get to see those of you in the room and to talk to those of you guys on the internet via this owl thing. I'm supposed to stare at the top of that. Is that right?
That's
cool.
The camera. Yep.
All right. So today, let's get into it because we're short on time. I've got a ton of graphs and things to show you guys. I'm really excited to present this project. It's called Work2Vec, learning the latent structure of the job market. And this is work that I've been doing with Erik, as well as Sarah and Seb here at Estelle. Also, a big thank you to Max Fung. He's done some amazing engineering work with our team as well to help us scale this and make sure that we're doing the right thing and handling, hundreds of gigabytes of business. All right, so the big question for everyone here, something that a lot of you might be thinking about already, is how do we understand economic dynamism, but generally within that, we have the question of occupational dynamism. How much are occupations changing over time? And can we measure that? All right. So why might we care about that? One is that the occupational themes, the occupational changes in the economy are going to pick up a lot of the larger scale economic trends. To the extent that anything is going on in the economy, it's going to get piped through labor as well. And getting specific on some of those trends, we're thinking about new technologies. So the question of where is automation going to affect different types of work? Where is work getting reorganized and changed, and how are companies changing digitally? I'm not going to talk about this a ton today, but globalization is another area where you might want to think about this stuff, especially as we've had trade wars or changes in trade policy over time, offshoring maybe facilitated by remote work. That's kind of getting into the COVID introduced trends in the economy, as well as possibly shifting consumption. Just as some industries grow, say healthcare, education relative to others like manufacturing. How can we see how the work people are doing is changing in response to that too? So this paper, we're going to take sort of text data to create spatial representations of work. So think of like, we're looking at the universe of work in sort of a portrait analogy sense. You've got, maybe that's planet salesperson, and then we've got planet software engineer, and, welder somewhere else. So we're going to try to measure some proximity between different types of work and then see how those planets are moving relative to each other. Okay? So that helps us say some things that are big picture about the job market, and also sort of more micro about how specific changes are going about. I'll explain what that means in a little while. This is going to be primarily descriptive work to start, but if you're going to think about one question that this work can answer, it's going to be a big question: what is the rate of creation of new work? Right now, that's a near and dear topic to my heart as well as my co-authors on this. When we think about the rate of creation of new work, we can compare that to, say, the rate of automation of existing work. And if the rate of creation of new work is super quick in gross terms, then it's not the absolute loss of jobs that we should be worried about. It's the distributional impacts and how to mitigate those. That's where policy efforts should be devoted, not the, say, concerns that we're all going to be, fox hunting in our leisure time, as opposed to. So, all right. So some, oops, I guess I accelerated a little quick there. Looks like my clicker has died. So, Megan, do you mind handling that for me? So, this might have found I had a little quick there. All right, so yeah, next slide here. Sorry, clicker. Or maybe it's, now it's, okay. So one of the things, all right, so why do this project from an engineering sense? Well, better information can reduce frictions in the labor market. That leads to better outcomes for workers and firms. So we think about displaced workers. Sarah's done a ton of work, really great stuff in that area. You know, I'll give you guys an example, a historical example about that. But you know, if your occupation is declining as a proportion of what people want, say it's this demand side, for example, and as you're getting kicked out of your job, you might be facing declining opportunities as opposed to you're displaced for some other reason that has nothing to do with demand and the opportunities are available. So thinking about supply and demand, how those things are shifting around, we're going to try to give some measurement techniques to figure out what's going on. And just more broadly, we want to measure the labor market in real time. And one of the great things, something that's been hiding in plain sight for years until modern deep learning techniques have unlocked it for us, is job postings reflect a lot of those changes that are happening. So that's going to be our primary data source. To answer the question of how quickly is work changing, we're going to take the job postings, the signals of what employers want, to measure that and build some, sort of geometric representation. So, lots of applications there, try to get college students better info about what sorts of career options they face so they can make good decisions about what to study. We can help people decide what jobs are near to each other so that if you're considering a career shift, some jobs are far away, like to convert me into a brain surgeon would take, heroic effort. But maybe I could do something else like teach a different type of management science or something. So two goals for today. One is to show you all a little bit of these early results, but also to talk about these new methods. I want to underscore that point. We're not looking to innovate per se in developing brand new techniques that advance accuracy in deep learning. We're not computer science researchers in this sense. We're trying to be among the first to deploy deep learning in economics research. So think of this like linear regression is everywhere. We hope that deep learning will be everywhere too. It's a useful set of tools for the right question. All right. So how do we think about occupational change today? Well, I really like this framing in a paper by Jiaoqi Chang, Doki Li, and Sunny Tenbei. They looked at the creativity literature. So they're looking at patents too. We'll talk about that a little while, but we can think of a few different types of job innovation. So maybe we've got two jobs that are totally different from each other, but you can push them together, recombine them in interesting ways, and then you get a recombinant type of job. So think of that as like linear combinations of different types of work. There's also sort of frontier expanding new types of work where you invent a new thing for someone to do, and that's kind of expanding the space. And then they have another category which they call transformative, which is, we're going to kind of lump that into the last set that I discussed. But transformative would be like adding a completely new axis, the type of work. It's not doing more of one thing or doing a more extreme version of something. It's like just completely changing what's going on. Think like the first time punch cards were used to program computers or something. So what we're going to do basically is chunk job postings into a model. We're going to represent them using BERT for those of you who are familiar. And then we're going to push that out into a few different sets of models. I'll describe those as we go. All right. So, we're gonna give you a bunch of different tools. We're always open to listen to new ways to collaborate and how people might deploy these tools. So stay in touch with us on that. And if you have ideas, we're happy to take feedback. So let's keep this interactive. All right. So some punchline things. We see an expansion of the size of the job space over time. We only have data from 2010 to 2019. We're pulling in data that's more recent, via the COVID times, but we're going to end the sample at 2019. We see an expansion of the types of work people are doing in that period. There's very little destruction of work. So the things that people are doing, this isn't necessarily an intensity measure. It's if someone was doing something in 2010, there are people doing that thing in 2019 as well. That fits with the Alvarian pointed this out. Or I'm not sure who originally did maybe it was out, but there's only one job that's been automated fully since the post-war era. Anyone know what that is in this room? I mean, Erik, you probably
Yes.
Any guesses? All right, it's elevator operator. I did present that once to a group of people, and one guy said, "Well, my building is an elevator operator." I said, "Yeah, you're kind of proving that point." Anyway, so that's not necessarily a surprising result, but we were excited to see it. And then we're gonna show you some heterogeneity across firms, across workers. All right, so let's get back to this big question, like thinking about what the future of work is, by maybe going back in the past. There's a really beautiful paper by Feigenbaum and Gross talking about telephone operators, switchboard operators from 1920 to 1940 or so. So a switchboard operator at that time was an entry-level job, often taken by women, and it was a good way to introduce them into the workforce and give them opportunities for like a leg up later. AT&T decided to roll out automation technology. And one of the cool punchlines of this paper is if you were in a later cohort, like post 1940, you weren't really damaged by this. All right. Now, if you were in an earlier cohort, obviously, you're living in the labor market, this is going to hit you as badly either. But if you were in the middle, there was a displacement effect where those people face worse prospects. So to the extent that we can measure what's happening to these folks in real time, the modern day switchboard operators, by the way, switchboard operator is still a job. It's just taking like a stick out of a system and sticking it in another stick to connect calls. Very different job now. We want to be able to measure this. All right, so keep this example. All right, there's a large set of literature that motivates a lot of the coolest conclusions we have. So we're standing on the shoulders of some real giants here. But from a technology perspective, we know that technological changes shift around labor demand. They also shift around labor supply. And there are winners and losers when this happens, both at the firm level, occupations, contracting, the whole script can change, especially over the long run with the general purpose technology. Okay. So, we think about remote work now, and I'll show you guys an example of remote work. There was a whole concern about offshoring decades, not decades ago, but a few years ago, we were worried about offshoring, and it seemed like actually that didn't happen too much. Partly because remote work, I would hypothesize, remote work hadn't come to dominate knowledge work throughout the economy. Now that we're seeing remote work proliferate, we're realizing, this works. Maybe it's time to start thinking about offshoring again, especially when it comes to that could be a great thing for the world, I think, as we see living standards increase as knowledge work goes from supply. Just some food for thought. All right, so another really, I'd say, gorgeous theoretical paper that I absolutely love is this Asamoah race between man and machine paper. There's kind of a mental framework here for why we're measuring what we're measuring. So if you are a firm and you're deciding, what should I automate? You can line up all the tasks in the world from easiest to automate to hardest to automate. And at some point, it's impossible to do something. Somewhere along the line, you hit a point where the returns to automating are about equal to whatever the cost to do the labor is. That's your marginal automation task. Now, when you do R&D, you can invest in shifting that task out. You can make it a little bit easier to automate, and then you shift what labor was doing into what capital is doing. As you squish everybody into a smaller and smaller set of that continuum, the last set of tasks to be automated, labor is really competing heavily there. The supply is getting shoved down. Maybe demand's going out because of all the automating we're doing too. But at the extreme end, you think about like a perfectly inelastic demand curve. Every time I drive the cost of labor down, it's just not consume the same amount, but or I hire the same amount, but I'm shoving that price down. Now you have a huge incentive to figure out a new way for people to do things with this super cheap resource, all these smart people who could do things. So that leads to an incentive to create new tasks. And when you create new tasks, you create complements as well to all the old stuff you're doing. And that's a different kind of R&D. So there's this natural tension in the economy between investing in new tasks to do things and automating existing tasks. And you have to think, if you're a firm, what do I want to do right now? Okay. The thing is, in this model, that new task creation thing is a scalar, but that you don't have to invest in new tasks in one direction. You can invest in a lot of directions. Turns out the right answer is about 30 directions. Okay, so we'll show you a model that does that. But we want to be measuring this new task creation rate and seeing, how is it distributed across the company. Any questions so far?
I'm going to give a concrete example of a new task creation like we have in mind, though, with Asamoah stuff.
So there's a few different examples. One easy one that I brought up, right? So we've got punch cards. So we're going to invent new ways for people to routinize work by creating code, and that extends even today, where things like TensorFlow, which make it easy for people like those of us economists at the lab who aren't bred in computer science. We can train deep learning models now. So new task creation right in this project. Or you have things in other places in the economy, like what happened to switchboard operators. Let's forward here. So here's a switchboard operator now, job posting for a switchboard operator in Wilmington, Delaware. You know, the kinds of functions they have are not actually routing calls. It's answering calls, but then it's maintaining a pleasant, courteous, and calm attitude, assessing the need of the caller and transferring it, answering the private physician line and making necessary pages. Like there's some customer service here. There's an understanding of where people are coming from. That's not, you know, hello, how can I connect your call? Okay, done, finished, right? That job.
What year is that from? Is that current? Is that next?
This is from, I think, 2019. I don't know when that is.
People still doing
This
that.
is in our data set somewhere, but
And this is the kind of text that you're going to be analyzing. This is an example of a job posting.
exactly. So, you know, it doesn't look this pretty in our data set. It's just a blob of text with a bunch of different characters. But yes, exactly. So this is the sort of new text. See, we're getting a couple things in the Q&A.
So there are two clarifying questions in Q&A that this would be a good time to ask them. One from Andrew von Nordenflecht is, given this is a text-based analysis, are you limiting this to English-based job postings?
Yes, so we were using the English for this one, though you could easily imagine extensions to wherever people have already trained language models. We're currently not in the business of training our own language models from scratch, but if someone's got, you know, a corpus in another language and there's available language models, we'll take it.
And another question from Vaclav Horolek Jack is, well, it's a long question, so let me just, his basic question is that his opinion is a lot of online data is polluted and many online job postings are fake. And that maybe his guess is that maybe as little as 35% of online job offers are finally assigned to applicants. Do you take that into account, or what are your thoughts on that?
So a couple of things there. One, I think posting a job for a worker you don't want is a little bit of a costly signal. You're probably going to adjust a whole bunch of data at that point that you may not want to sift through. So we are taking these signals as genuine from firms. Probably that's sort of an assumption embedded here. Nevertheless, even if a lot of them are fake, but still adequately describe the work that they're hiring for, that's okay, because we're measuring how these jobs are changing. So we thank them for their free data if they were fake. If they weren't, then, you know, thanks also.
Okay. And I think I'll also give Morgan Frank's question to you, which is a little bit more, but yeah, hi Morgan. How has the quality of older jobs changed? I think you started talking about that a little bit earlier.
The quality, like
The nature of older jobs, yeah.
so we don't go much before 2010. I'll show you more in a little bit of a time series.
Okay.
Stuff. But
I'm
there
not
are
sure,
other
but maybe he was thinking about, you talked about these new jobs in the frontier, but there are also changes on the existing, like the inframarginal.
Oh, for sure. There are definitely inframarginal changes. So actually the measures we're going to have are more gross terms instead of net. It's not just the marginal changes, it's how every kind of change. Yeah, good question.
Feel
Do
free
you
to
want
elaborate on that, Morgan, if we didn't get it quite right.
Yeah. I think Morgan, you and I have a meeting at some point this afternoon. Yeah, if you want the longer time history, Engin Adelaide and his co-authors have a nice paper comparing from 1950 to 2000. That's probably the closest paper to what we're doing here. What they find is 88% of the shift in what people are doing is happening within occupational groupings as opposed to. We're going to use burning glass technologies. That's where our job postings data is coming from. That's a commonly used posting. It's as they say, the near universe of job postings. There are some compositional differences. I'll talk about those. Okay. So I mentioned this briefly earlier, this Chang-Li and Tanbei paper, which talks about these different types of innovation. If you're curious about how some of these results might look in the patent space, especially which artificial patents you can generate using some of these technologies, they do some cool exercises. So lots of other papers, happy to discuss those often. All right, so
you're not going to explain the colorful graph?
Oh yeah, well, we'll get into this for the job posting world, but this is sort of within the Chang paper, and you have different groupings. So this is like two axes. These are meaningless axes, but they represent some coordinate system. There's some patents that are kind of green type, some that are black type, some that are purple type.
Combinatorial exploratory.
Yeah, so you might imagine combining a purple and a green type and ending up somewhere. So for the management folks in the room who want to think about how to apply these deep learning and economics methods to what they're thinking about, this fits in pretty well. Let's say the resource-based view of the firm. How do you think about the stocks versus flows of talent of different types? Think about at the firm level, who's got which types of employees? How are they changing? What might be firm specific, which means you get profits from it, as opposed to more general types of human capital where those returns are competed away. That leads into the breakdown of returns between employees and workers. You can also see when there's a new technology, a new way of doing things, how quickly does a firm start to pick up those types of work? So if there's an innovator in a certain industry, they might have copycats later on. If they can copy quickly and deploy it, that indicates something about the absorptive capacity there. So there's a bunch of these other theories. But just to say, we're not just thinking about this from an economics perspective, but also a strategic management. So talk about that. Let's dig into the data a little bit. So Burning Glass is a lot of the job postings that are online. It's by no means perfect. You do have pretty big compositional differences across job postings. I think if I were to just get a job posting randomly selected out of the data set, and you asked me to guess what type of worker it is, most recently is nurse. It might be truck driver or salesperson. That's kind of your base rate. So if you're building a predictor, what job is this? And you just said nurse all the time, I think you'd be right more than you'd think, I suppose. We also see massive growth in the number of job postings. This is sort of one of the big caveats for the work and something we're trying to found as an error source. Firms are adopting job postings online throughout this period. So the type of work that's posted online might be changing as a result. Let's see what else. So when it comes to farming, fishing, and forestry over here at the right, we don't see a ton of job postings activity. They're also not a huge piece of the economy. I think we had one of the lowest categories. There were like 64 postings in the whole data set for dredge operators. So if you were looking for detailed granular data on a dredge operation is changing, I'm sorry, I don't have good answers for you there, but we do try to put some things. Okay, so here's kind of the length of the postings too. So we have BERT as an input here. BERT only takes 512 tokens. So we're gonna have to click these at some point. You can either take the first 512, you can randomly select it, take the last 512, but you can see there's a big tail of text information that gets chopped off when you do that. And that is one way to augment the data set. So you clip it at different points, and then you reclassify. Some of the content is sort of standard legal language or information about the firm. That's not going to add a lot, but it does add in some nice penalization for us, because if that doesn't indicate anything about the type of postings that we're going to get, we're adding noise into our training, and that's going to help mitigate overfit. Our model's got like 110 million parameters. At some point with a lot of these deep learning methods, you start to overfit. Okay, so I'm going to skip ahead because I want to, nurses was the most. Software engineering, a lot of truck drivers on there. Okay, so first thing we're going to do is try to mitigate the sample issues by saying if you're 75th percentile or greater for the count of postings that we have, we're going to chop you off there. We're going to only take that 75th percentile amount. Everybody else, all their postings are included because we've got that long scale of different types of things. It's a little bit hard to read. My apologies there. But basically, our predicted class, if the output of the model is which job type is this, and the input is the text, our predicted class tends to line up pretty nicely with our actual class. So that's a good sign. Now, all right, why are we using BERT? This is just a point for those of you who are going to maybe build models like this for yourselves. A lot of the language, if you use something like Word2Vec, Word2Vec doesn't have context, but you need context. So we've got two postings here. One is for a senior machine learning scientist. The other is that's at Amazon. And the other is for a machinist. That's at Anheuser-Busch. A lot of the language in these postings is really similar. Okay, machine means different things in different contexts. So if you do this in isolation without using the word context, you're going to get some really bad outcomes. Instead, BERT is nice. It's a bidirectional encoding. That's the B and the E of BERT. So that means that all the words around the word are used to predict what that word might mean. So when you get a numerical representation of the word, it includes the context where it's placed. So that helps you do better classification. All right, and I'll skip over some of these other examples. Just to say, if you wanted to look at Python, obviously we're talking about coding a lot of the time, but if you use Work2Vec instead, you get Monty, Chapman, Cleese, Graham, Circus. We're not trying to force people into becoming comedians on the margin. So
are there a lot of job postings for Monty Python?
Yeah, or snakes. That's the other one. So if we want a bunch of zookeepers and comedians, we'll end up switching to that stuff. But Python is a coding skill is probably more often. So we're going to use word embeddings the same way you might use Word2Vec, but we're going to use BERT, so it's got some context. All right, I'll skip over how this works in the interest of time. Our model for the classification thing, again, input job text, output which job is this, which one of the 824 or so categories that we have enough data to do this for, which one of those is it? It's going to take the whole BERT thing, so tokenize the posting, stick it through BERT, and we've got a one-dimensional convolutional layer. Just kind of filter this window over the words, get more context out. I'm going to do some max pooling, which takes the maximum of those convolutional layers, and then you flatten it and just do basically a logistic regression. So
I think you kind of answered this question, but Max Wang was asking how many total skills do you have, and you considered when you did the contextual meaning of skills, the same skills may have different meanings, different contexts. But
yeah, I'm not sure how many total skills there are. We're not doing any of the named entity recognition here, but we have 824 jobs. So you can think of
the ballpark of the number of skills that
the skills are not part of this analysis.
Okay.
So that is something. Here's a kind of graphical representation of the model. Thanks, Max. Job text in. At the end, we get an 824 dimensional vector. These are probabilities that you belong to each one of these classes. So, 24% you're a software engineer, and 76% that you're a nurse or something. Right? So those things let us do stuff. You can think about those being our coordinates in 824 dimensional space. This is where planet software engineer, planet nurse. Okay, so how do we do an accuracy for this type of model? Pretty well, actually. So if you're guessing at random over 824 classes, your accuracy is not going to be very good. We nail the exact category that Burning Glass provides, which by the way is, as a source of ground truth, you don't want to be perfect there because Burning Glass has a view. We're not saying it's perfect necessarily, but what we want to do is learn structure in the postings. So we're using a supervisor approach to do something somewhat unsupervised. In this step, we get top 1 accuracy about 3/4 of the time, top 15 accuracy about 95% of the time. And when you make an error, it's usually some kind of similar job. Instead of salesperson, I get sales engineer. Or salesperson of it, right? Like these categories have this. You can see this graphically. So we got our different categories lined up. The actual class is the x-axis. The predicted class is the y-axis. That diagonal starts to turn red. That's where we're, hitting predicted and actual are the same thing. The off diagonal where it's white, we didn't make any mistakes. Where it's a little, but you can see there's a little bit left in the table here. That's okay. So this was actually taken like a snapshot taken mid-training. We start to get these ROC curves across multi-class things that look good. If the best thing you could do with a multi-class ROC curve or any ROC curve for that matter is top left. That would be perfect. I'd actually be really concerned that we screwed something up if we were on that. Nobody's very pleased with multi-class. All right, so things. Why would we train a classifier? But first of all, it's useful, I guess. Well, we'll open source this eventually. It's useful as like a thing people can use. I got text, I want to know what job this is. Possibly helpful. As I mentioned, we want to learn the structure, how these different postings relate to each other. Having a target can be useful there. And then obviously we have the reason having a target useful there is we can look at it and say, all right, well, is this making mistakes in unpredictable ways or making mistakes in predictable ways? All right. And then
this is in terms of that. So there are 2 questions kind of related.
Yeah.
I think you kind of already just Matthias Chan says the BG occupations are all that accurate. I think you touched on that a little bit. And Morgan Frank says, did you validate any of the examples by hand?
Yeah, we've validated a bunch by hand. They tend to be pretty reasonable. So that kind of answers both. We don't take Burning Glass's full ground truth. We're going to be doing, for this model, we're going to be doing a lot of things where we diff out the effects of whatever the Burning Glass label might be. I'll show you guys.
And while you're at it, maybe Andrew Ashlon also asked about how you dealt with duplication of job posts and different boards.
Yeah, so I think think burning glass actually deals with that fairly well. We don't do that stuff ourselves. Yeah. But so just as an example, if we're training with a duplicate post, that's also going to be somewhat equivalent to putting noise into the model. You worry about overfitting to that post, but it might create a little actually unclear. But I'll show you guys the substantive reasons right now. We have this technique that we're sort of inventing for this category. And there are some similar things out there, but we're going to call this a text injection. This is the first. You can think of this as we build this surface of all these different postings and it exists in some high dimensional space. We want to move around the surface by putting different ideas into the postings and seeing how that classification changes. All right, so sometimes it's really difficult to say this is the mathematical representation of an idea that I have. What's nice about these things is we can represent our ideas verbally and then stick them into a computer that represents them numerically instead. All right, so what we're going to do is take a line like this. This is a full-time remote position and employees can be based anywhere in the United States. And we're going to snip out part of a job posting. And we're going to replace it with this line. Okay, now you stick both of these postings, the original one and the modified snipped one, back through the model to predict what the job is. And we're going to get that 824 dimensional vector for each one representing jobs. So if you diff those two vectors, what you get is how much did my posting prediction change as a result of having remote work ideas in the text. And if you change a lot towards that job, we think, okay, this is more likely to be a remote work kind of position. There's a more remotable job. If you change away from it, that's someone who's got to go into work. That's someone who's got to do that. So what we found was the most frequently predicted occupations when you do this were things like office and administrative support workers, managers, computer support specialists. Food service managers was sort of interesting. I thought, no, there's no way that's remotable. And then I went out and looked it up in ONET. You know, of the 25 or so, tasks that food service managers do, maybe 23 of them are things you could do remotely. And the last ones are things like checking inventory. Those are things that you could offload to someone who is actually on site. So actually it's sort of a remotable task. On the other hand, if you're capital intensive or you're serving food, or as we've seen through the pandemic, trying to teach elementary school children over Zoom, it's very difficult to remote that kind of work. All right. Truck drivers as well. I did have someone once say that all truck drivers work remotely. Not totally wrong, right? But you can't always bring your capital with you as well. All right. So we wanted to validate that too against existing measures of how remotable jobs are. So you regress. There's this nice paper that kind of came out in the middle of the pandemic. I think Neiman that said these are the jobs that are remotable. We regressed those scores on our scores. There's a few different specifications: logistic, probit, loaded, and the linear probability model. The scaling, don't worry about the coefficients too much, but we found positive and significant results. So that one's based on human judgment, where they go through and they say, okay, this job's remotable, this one's not. We auto-detected human judgment using the job postings here. And you can kind of see those things line up here as well. So this is work that Erik, John Wharton, Ed Lozenek, Garima Sharma, and Ami Tuye have done. We looked and we saw, a lot of the managerial roles, professional occupations, they got remoted early in the pandemic. Keeping in mind, all this data is from the pre-pandemic period. So we could have predicted, from our data, for sure, all these managers are going to be working from home. Or good. You can do this with other skills. So we do this with a few tech skills. If you add TensorFlow into a posting, you get a lot of web developers, computer systems analysts, computer applications. That's where we want to see it. Probably not too many elementary school teachers using TensorFlow yet. Parking lot attendants yet. Mental health counselors. But you did this for R and SQL. You got computer information research scientists. There you go. People who are R fans. Recreation workers, dining room attendants, bartenders, they're not using R and SQL too much. All right, so let's see how much we got.
So maybe you could do maybe 10 minutes more and then have general Q&A.
Yeah, let's skip over. If anyone's curious, hit me up. I'll show you whether or not this person did what you did. All right, so that's the first model is a classifier for text in, jobs out. But that doesn't help us measure distances between things. Okay. To do that, the reason that doesn't work is imagine, instead of space, every everyone's speaking different language on different islands, and all we need to separate job types is a little bit of water between them. When you're training, whether it's a little bit of water or a ton of water, it doesn't matter. You can still cleave these islands away from each other. So that makes your distances contingent on how much time we spend training the model. When you use a variational autoencoder instead, so in the last round, we're going to take the input as the probability vector, we're going to cast that in an encoded space that's lower dimensional, and then decode it back out to the original vector. So you have a lossy compression there. That's penalizing space in a different way. So that instead of this, I don't know how far away these clusters are thing, we're going to regularize, normalize that space so everybody is close together. There's a penalty for overtraining or undertraining. We got distances out of that. All right, so, this is our new model. It's got this full variational autoencoder space on the end. And we've got to skip the technical details.
Well, okay, there are a couple of questions about the technical side, so I'll just combine a few. One is, could this be useful for combining job descriptions into one-liners? Is there a case that's from Shalimile Chandra? Zubin Wadia asks, I think you touched on this a little bit, but is there a case for longer context windows than 512 tokens? And that in some cases, much longer postings have more information. The citation that I'll show you later. With Dia Ahmed, and I think you may have touched on this as well, but how much of each job description is used for training, and you move around those 512 tokens to cover the summary at the start or other parts of the job list?
Yeah, so I can talk to you later about how that moving around works. So the first question, that's more of a generative question. I think that's really interesting, like create a précis of all these different job listings. We haven't really looked at that. For the second question and the longer one, we did try to train the long former model. We were having some trouble with that, so there's still some engineering TBD, but agreed, yeah, if you can get the full posting together, that's good. All right, so there is a hyperparameter here where we can choose, though, for a variational autoencoder, how many variables are we casting things down into, right? So if you do 5 factors versus 50 factors, how much does that change? This loss function shows you can think of what are these underlying changes going on in the job. If you think about the genotype of a job, like how many genes are there that move around, right, to recombine? You do it with 5, you get a boost, but there's still a lot left on the table. Do it with 45 versus 40, there's not that much of a gain here. So we kind of pick 30, which is this brown line here. That's where our stopping point is. Okay. So we're still getting a lot of gains out here. We have a 10-dimensional model as well. You can see that's capturing most of the variation too. Now, these are not interpretable factors necessarily. We're going to have to look at it. I don't know what that is, but we can do some work to figure out what that. All right, so there's more on the loss function. This is what it looks like. These are our 30 dimensions. We have a normal prior on them. That's why they're all in Gaussian shape. But think of this as we have a 30-dimensional Gaussian that describes all the different factors that are affecting jobs. So let's do things like, let's pin all of these things at their mean value. And then, except for one dimension, let's go from an extreme value in that dimension to the other extreme, like 2 standard deviations down versus 2 standard deviations up. And you get a movement from, say, in factor 1 here, first line supervisors of retail sales workers through to logisticians in the middle. Logisticians tend to be in the middle for everybody. They're kind of like your stem cell of jobs. Over to health technologists and technicians. So those retail supervisors and health technicians are opposites.
Wait, sorry, can you point to, maybe give a pointer or just, guess not. Say that again. So
right here, I don't know if you can see my little.
Yeah.
So first line supervisors in factor 1, we're moving from like extreme -2 to 0 with logisticians.
Okay.
Then we're going through cardiovascular technicians all the way down. My favorite one of this is that oral and maxillofacial surgeons are like the opposite of missile and air defense crews in some way. It's probably good. I've never seen an oral surgeon use a missile before, so a little bit of face validity. Anyway, we've got 30 factors of these. They go through lots of different things. So you go from like social workers, again, to logisticians, through compliance officers, and then over to counter and rental clerks, travel agents, and industrial engineers. In this one, you can kind of think about what these might be, like surveyors, and some people are always at home are kind of opposite. So it's sort of like a get outside and do your job factor. But we can decompose all the different jobs into these set of factors, and you get this kind of messy graph that looks like a genotype spectrum for the job. So, and then on the left here, we have how many postings there are. So this is for a commercial pilot. The factors for commercial pilots are pretty stable. Their work hasn't changed a ton in the last 10 years or so. But we have had a lot more postings. So, and these are different things here. Let's interpret some of them. So we've got like office clerks. Office clerks, part of the job hasn't changed a ton. We got a ton more postings, but like we got a movement up in factor 16. So that's like going from a social worker towards a clerk. In 26, we've got information service manager. They're becoming less like information service managers, more like customer service agents. Movement or down in 18 again, so away from CEOs, that would be like one extreme, and towards like delivery drivers. So this is sort of an example of office clerks getting de-skilled in the sense that, or perhaps not de-skilled, but move towards lower wage kinds of elements. So logisticians are kind of middle of the road job. They haven't changed a ton, but to the extent that they have, these are the factors that move the most from engineers and techs towards ticket agents. And then, away from surveyors towards typists, they're going indoors. So computer systems manager, this is all kind of the same sort of thing, but no matter what you're doing with the counts of postings, if the quality of the work, the things we use to describe it is changing a lot with respect to the number of postings, that's a problem for us. Instead, we see stability, a lot of different things. So you can look at that too. I will not, in the interest, I'm not going to talk about very
Yeah, that's kind of the volatility is going down.
Yeah, volatility is going down. A lot of that's going to be from more sample size, so it's kind of a handful factor. But logistician are getting less complicated as they tend towards lower wage. So you can do this with employers too. So what do you guys think Stanford is? If I were to take, it turns out when you combine these things and average them and stick them back to the decoder, you can get a prediction for a job. Stanford's got them. I was sort of surprised by this one. To give you guys some context, USC is like a college professor.
Football player, Stanford football player.
Football player, yeah. No, with the team, just nice. Big, honest question. I don't know who this is. But it turns out Stanford's a management occupation. A lot of folks doing management here. This, by the way, Stanford's a little different because the healthcare section is actually qualified as a different employer. So we stripped that.
Universities in general become more administrative.
Yes, they have. We could look through that. Yeah, you can know that from just looking at quantities of people hired. How about Facebook? Who knows what Facebook would be? I guess software. Yeah, I thought it'd be a software engineer too. It turns out it's a public relations specialist. So, shout out specialist at Facebook. So it's kind of interesting. This is some other work that I'm doing with Sunny Sandray and Barry Wing. You can decompose the types of work and the types of skills that people are doing at different firms and see like this is a point array embedding. I call these Death Star plots. And you can see if the center is the firm and the yellow stuff is the jobs and the white stuff is the skills, you can see where firms put their chips. So the left side is Walmart. They do a little bit of everything. The right side is Google. So Google doesn't spend a lot on operations management, facility management, those people, admins. They spend a lot on sales, marketing, and tech. Walmart is a big, complicated business that does everything. All right, so
this kind of gets to some of these questions, but let me just one asked, is this the same or how does it differ across regions and seniorities? And another question is, how about doing it by wage or salary bands or white collar versus low skill?
Yeah, we're in process on a bunch of those things, but I don't have good answers for you. Not every job moves the same. So that's another thing we can look at is how much does a centroid of these within job categories move around. So that's the left-hand plot. How much did your centroid move from relative to each previous year with the 95% confidence interval around it? Thanks, Jacob Furlong, for putting some of these graphs together. And then we've got for each year, how far is the average posting from the centroid, the typical like modal answer for that posting. You can see some interesting patterns. So like athletic trainers have kind of a constant-ish drift every year. They're moving some amount, some consistent amount. That's how much volatility there is in athletic trainers. But they're getting a lot less far away over time from the centroid. So there's some consistency, additional consistency in athletic trainers. If you look at cashiers, There was more drift year to year before, now there's less. And they're also consolidating, becoming more uniform in terms of what they do. You can look at paralegals. There's less drift over time for paralegals too. And the average it was getting much more consolidated. Now it looks like there's something different going on for paralegals. Might be as a result of deep learning, for example, pretty much just speculating. And then maintenance and repair workers, they're moving around a bunch too, but also kind of becoming more similar.
So that's, well, a lot of them seem to be getting more similar over time.
Yeah.
So
as you get more and more people, coming in to do that kind of work, and there's sort of a solidification around the concept, then yeah, that could be happening. I don't necessarily know why it is, but that's not a factor I've seen established. We can look at, by job where the lowest versus highest diversity types of work that people are doing. This is in 2010, speech and language pathologists were the least diverse. They were most kind of settled in terms of what they were doing. Computer programmers and human resource specialists, they're the ones that are changing the most, or cross-sectionally changing the most. Now, if we look at 2019, a lot of medical stuff, and people are pretty consistent in what they do area. And it's a lot of computer and educational stuff on the other side, where there's a wider range of what people get. This is sort of what that looks like over time. So the scales do differ quite a lot. So these are groups where the volume of all those postings, that's another way of thinking about it, that's moving around a bunch here. But within that little line that's flat, that's these three jobs here. So you get kind of the scaling effect where a lot of the volatility, a lot of the volume in terms of what people are doing is changing as a result of the small, they're kind of a tail group of workers. There's some work that just doesn't change that much. Baggage porters and bellhops, sales engineers, and paralegals are mostly doing very similar things as compared to management analysts or stock clerks even. People are asking for different stuff in the jobs that are classified as those things. Okay. So let's think about the whole economy now, the last couple minutes. Now, this is what that space looks like projected into 2 dimensions in 2010. That barrier on the outside, those are all the extreme jobs that constitute the convex hull. As we move from 2010 to 2015, we see expansion into the space of more extreme jobs. And in 2019, it's becoming even more diffuse. We're seeing a really, kind of large growth in the gross, quantity of new work that's being invested. A lot of that's combinatorial. So jobs that exist being combined with other jobs. And a lot of that growth is also the frontier moving out so that, there's new types of work. So I won't get into how we do this, but think of these as cumulative density functions, where we're going to resample jobs out of the space and calculate the volume of the hull that they represent. So how much space can be represented by that sample. And we're going to look, instead of comparing means, we're going to see if one distribution first order stochastic dominates the other one, and if there's a consistent pattern. So what does that mean? Well, is there more of a variety of extreme jobs, more volume represented by work over time? So we start from 2010, where it's all shifted to the left. That distribution of samples that we're drawing has low volume on average. And then it's monotone, actually. We were surprised by this. It was increasing into 2019. Every year, there's a bigger and bigger average space for the samples that we're drawing. So that frontier, the set of possibilities of new types of work, that's growing over time throughout the entire economy. And as we see, that's driven by some jobs more than others. You can see that not only is the mean size of that volume increasing, but the variance in those samples is increasing. So there's some jobs that are way out there, there's some jobs that are not, and we're filling in that space. So it's more consistent early on. That's kind of what that looks like in terms of, mean and standard deviation. What's interesting is there's a really big pickup that says people are kind of adopting job postings. It kind of slows down a little bit, but either way, you're looking at 4 to 5% of an increase per year in the gross boundary size, the gross volume every single year. So we're going to worry about automation. Let's not worry about new work being created as a problem. Or automation taking away all the work. Let's worry about the distributional impact. Who are the switchboard operators? Area looks pretty similar. So our next steps here. So we're going to combine that with some of our remote work scores. I think we've already got some results on that. It's pretty similar. You predict remote scores versus predicting the job and then multiplying that out to get the remote work scores. Looking at machine learning exposure, Erik and I have some other work on that, and also like occupational routineness. So one thing that we could really use some help with is like trying to link causal changes to these changes on the other side. So if technology changes in some meaningful way, or the trade flows are changed by tariffs or something like that. How does occupational demand shift around, how these genotypes move? So if you've got good ideas for how to identify some of that stuff, that'd be really helpful for us. Then we're going to try to operationalize some more of these tests. So just to sum up, we train a couple of these different types of models. We've got sort of a micro version, which is moving around on the space via text injections, and we provide an application remote work there. We've also got these broader measures of changes in the economy, changes in occupational dynamism that we're characterizing via a lot of different smaller changes in the intensive margin of the job. So public drafts coming soon. We're really excited about all the possibilities that using text data and text new advances in deep learning, what those possibilities mean for economics. So this is our first stab at that. If you want to take a look at another sort of concurrent first stab, Sarah Bana's job market paper on how these skills shift around salaries. It's a really, really nice place to start and very intuitive in terms of how.
So it's similar to what you did, but mapping it into salaries as opposed to market.
Exactly. So, valuing credentials, thinking about how the equilibrium for labor market shifts around as a result of some of these things. She really dives deep on that text injection stuff. All right, cool. So that's it. Thanks very much for your attention. I'll look forward to your questions.
So first, is there anyone in the room who has questions? Yeah, go ahead. Christy.
Me? Oh, okay. So I was interested in the diversity of the job postings piece. Like you said, a bunch of them were like healthcare workers. Like how much of that is just healthcare work has become so specialized, right? It's like more and more specialized versus the other kinds of work.
Right. Yeah. So when you go to, one hypothesis, right? You go to a lot of different training, or you have years in med school designed to teach you to be, pulmonologist. Pulmonology might change in ways that don't get represented in job postings.
Right.
You're expected to read papers, update your techniques, but if someone's like, I want a pulmonologist,
Right.
that means something, right? Like that job category means a lot. Yeah.
Just was wondering if you can elaborate on the convex hull plot. Is that a projection of the 824 space in just two-dimensional space? Is that what are you plotting each of the 824?
This one here.
Yeah.
Yeah, so this is a Umap representation, which reduces that 824 dimensional thing into two meaningless dimensions. So I guess actually, if you're close together in here, that means you're probably close. If you're far apart, it could be that the space is folded in on itself in some way. So they're not actually far apart, but expanding towards the whole. When we do the volume calculations, we're doing it in the
real hull has 824 dimensions.
Yeah, or 30 if you're using a 30.
Yeah, 30.
And like if you try to apply the sensitivity statement that you did earlier, where you placed the Zoom or the remote work statement within the post, how would you expect this to change? Because now that you see.
Yeah, so for that one, we're really moving around in the space. Now, an interesting thought experiment you might do is to pick a totally new idea, like the person the ideal candidate for this job will interact very well with our alien friends. Something like that. I think it would mostly be noise, but you could see if you do shove yourself out of there might be more interesting ones than interacting with extraterrestrials as a job list. But that would be like the 2019 perspective on that extreme version of jobs.
Why are there so many jobs that are like in the same category, right? Like just 5 or 6 dots in a row. That's all just one. First, I was different years of the same job.
No, those are jobs that show up as being really similar. So
and they happen to be.
Yeah, that would be like Google and Facebook both looking for a software engineer.
So it'd be like a bunch of companies all sort of asking for almost the same thing, but not quite.
Yeah, I'd actually be really concerned if we didn't see this.
Yeah. Okay.
So
it's interesting that they tend to be in like straight lines rather than clusters.
Yeah, those would be projections of that bigger space into very marginal differences. along
But
these
mostly
two
along some dimensions.
That's probably a ball. And it just looks like a line here.
Because of the way it's been projected.
Yeah.
Yeah, that makes more sense. You expect it to be more like a ball, right?
Yeah.
Other questions? I mean, related to that, well, actually, so let me just ask, you talked about some of the causalities. This is sort of like descriptive of what's
Yes.
happening. And you briefly touched on getting at causality. Why don't you say a couple more words about how one might do that? Maybe people in the room have suggestions as well.
Yeah, so some of the first places we're looking at for this are natural experiments. I mean, I've got a paper on what, for example, TensorFlow did to the market values of employer firms. We can use a similar kind of shock with TensorFlow to see how did that change the genotype spectrum of software engineers. Sort of.
And the idea is that that's like an exogenous shock that happened pretty suddenly.
Yes, let's see. If we can get that. Yeah, so let's take the Stanford spectrum here, right? And maybe we're all using TensorFlow here. We might look at the end of 2015, beginning of 2016, and see like a discrete jump in one of these factors as a result of TensorFlow being launched. So that's sort of a micro technological example of a causal shift. On the other hand, if we're talking big picture about the full economy, we see the launch of tariffs, and that has some lag and then starts to hurt people in certain industries. You could do sort of a shift share causal instrumentation for what did the tariffs do to labor demand, or which skills got affected by. To do that, maybe we use the 10-factor model. Try to actually name what some of those things are. Like work became less outdoorsy and more indoorsy as a result of that.
Yes, exactly. Yeah, great. So we are actually out of time. So thanks very much, Jamie. Appreciate the presentation. It said the paper's not quite ready. Is there a link or something people should be checking to get a copy of that, or should we have them send them to our website? What's the best way if people want?
Yeah,
to
well,
follow
I
up
think
on
we'll post this on our websites. Maybe we do a sort of release on Twitter or whatever, keep an eye on Twitter.
Okay.
And maybe Estelle can help publicize some of that when it's ready to go.
Do you think by the end of the semester?
Yeah, hopefully.
Okay,
Yeah.
well then we'll post it.
We're gonna
We'll
try to
post- one of the links will be here on our seminar web. We'll keep your posting there.
We'll try not to let this be the paper is always 2 months away situation.
All right. So next week we don't have a seminar, but in 2 weeks we'll be having Steven Pinker will be coming to Stanford and presenting his work based on his new book on rationality. So hope to see you all then. Thanks again, and we'll see you in a couple of weeks.